Hey class, Miss Anderson here. Sorry I am not in class today and I am leaving you with another video, but I think you can get through it. So we are going to be starting a unit on absolute value functions, and we have done absolute value equations, and today we're going to do absolute value inequalities. And I just want to remind you of a couple things. So remember that absolute value means the distance from zero. So how far a number is from zero on the number line. So if you remember, we solved absolute value equations and we said like absolute value of x is equal to 5, then we thought about that on the number line, and we know that 5, positive 5, and negative 5 are both 5 away from 0, 5 to the right and 5 to the left. And so if we had the absolute value of x equals to 5, there was two answers for 5. You could either have x equals positive 5 or x equals negative 5, because they're both 5 away from 0. So today we're going to talk about absolute value again, but we're going to be talking about absolute value with inequalities. And we need to think about those inequalities kind of as our boundary points. And so if we have the absolute value of x is less than 5, we kind of have to think about our number line again and what would make this absolute value true. So let's think about 5 and negative 5 again. And we want the absolute value of our x, which means our distance from 0, to be less than 5. So we know for sure that we can't go over positive 5 because that would be getting too far away from our 0. Because like if we went out to 6 or 7, 6, 7, then we would be too far, because the absolute value of 6 would be 6 away from 0. And we want the absolute value of x to be less than 5. And then we can kind of think about it the other way. We want to go in the negative direction, but we can't go any further than negative 5, because negative 6 and negative 7 would be greater distance than 5 away from 0. So really we want to be between these two values, negative 5 and 5. So any of those numbers between negative 5 and 5 would be, the absolute value would be less than 5. So for example, if you said negative 2, then the absolute value of negative 2 would be 2, because it's 2 away from 0, and 2 is less than 5, so that would be an answer. Or if you were on the other side and we went with like 3.6, the absolute value of 3.6, well, 3.6 is 3.6 away from 0, and that is less than 5. So that would work. And I left my circles open in this example because I didn't have an equal to. If you remember the inequalities, when we have the equal to, we shade them in, and when we don't, we leave them open because those values aren't included, because 5 is equal to 5, not less than 5. All right, so same idea over here, but we have the absolute value of x is greater than or equal to 3. So we kind of want to look at our boundaries or our number line again. So we have our boundaries of 3 and we have negative 3. This time we can include it because we have the equal to piece, but then we really got to think about it. This symbol, since it is pointing to the right, this is greater than or equal to. So when we are thinking of values that would satisfy this inequality, we want our x value to be further away from 0 than 3, or 3 or more away. So we really want to go the other way, because if we picked like or I guess we can't pick 3.6 again. We could pick -2. In this case, the absolute value of -2 would be 2, but 2 is not greater than or equal to 3. So that would not satisfy this inequality. So this time we would want to go with the numbers that are more negative, like -4. If we picked the absolute value of -4, that is 4 away from 0, and that is greater than or equal to +3. So -4 would be part of our solution, and same idea over here. 4, 5, 6, 7, those numbers would be greater than 3. So the distance from 0 would be bigger than 3. So when we are thinking about our absolute value, we're really trying to think about which numbers are satisfying the inequality, so that we either have the values are less than, so between two numbers, or greater than, we want it to be further away from our 0. Okay? So less than, we want it to be closer to our 0. Greater than, we need it to be further away from our boundary point so that it's greater than our number. So that makes our rules here. So again, it's based off of the absolute value sign that we start with. So if we start with these two symbols, which are either less than, or the less than or equal to, then we want to set up a compound and inequality. And if you remember the compound and inequality, it is when you have x is less than a number and x is greater than a number. So the and inequalities work like, they're the ones that are connected in the middle, like this. So less than this number and greater than this number, so between two numbers. So when we're solving an absolute value with less than or equal to, we're going to start by setting up a compound inequality, and we're going to start with an and then we're going to solve that compound inequality. And then we can graph it. Then if we start with greater than or equal to, so these are greater than or equal to, then that's our or situation, because we want the numbers to be 3 and bigger, or -3 and smaller, so that the absolute value is always further away from 3 than 0, if that makes sense. It's kind of hard to explain. I hope you're following me. All right, so if you start with greater than, we want to start with an or inequality. We're going to set it up like this. So x is greater than our number, or x is greater than our negative number, and then we're going to solve the inequality. Okay, so let's just decide if we start with the absolute value of 3x is greater than or equal to 18. So we're going to look at this symbol. If we start with greater than or equal to, we are going to be solving an or inequality, which means we're using the outsides of the boundaries. So the inequalities going on either directions, left and right. And then if we have the absolute value of x minus 7 is less than 16, then we are starting with less than, and so we want and, because we want our numbers to be between our two boundary points. All right, so let's go ahead and solve those. So if you flip to the other page, so we'll do a few examples. Okay, so we have the absolute value of 3x is greater than or equal to 18. So since we have greater than or equal to, we want to do or. So what we're going to do is we're going to split this into two equations. We're going to say we have 3x is greater than or equal to 18. So just the original equation without the absolute values. And then it's going to be or 3x, and we're going to flip the inequality. So we have less than or equal to, and we're going to make the 18 negative. Now we're going to solve each one. So the 18 and the negative 18 are kind of our boundaries. And now we're solving for x because we're going to use figure out the x that satisfies this equation. So if it's 3x, we're going to have to divide by 3, and we're going to get x is greater than or equal to 6, or we're going to divide by 3 over here as well, and we're going to get x is less than or equal to negative 6. So we're going to put that on our number line. I'm going to put 0 in the middle, and to make sure that I can go from negative 6 to positive 6, I'm going to count by 2's. So I'm going to do 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8. We have a greater than or equal to, which means we will need the closed circle inequality. And then we want to graph the x's that are greater than 6, which would be the 8, the 10, the 12, so to the right of positive 6. Or we want to graph x is less than or equal to negative 6. So we can go to negative 6. We're going to have a closed circle again. And less than is going to be to the left because negative 8 is less than negative 6. So these are the solutions that satisfy the original inequality. And what I mean by that is if you pick any of the numbers included here, so like 6, 8, 10, 11, 12, 13, 14.5, negative 6, negative 8, negative 8.7, negative 9, they will make this inequality statement true. So let's just pick 8, for example. If we go back to our original, we're going to have the absolute value of 3 times 8 is got to be greater than or equal to 18. Well, 3 times 8 is 24. So we're going to get the absolute value of 24, and that's going to give you 24, which you know is greater than or equal to 18, because 24 is further away from 0 than 18 is. And it would be the same if you did negative 8 the other direction, because you get negative 24, and it's the absolute value of negative 24, and the absolute value of negative 24 is 24 because it's 24 spaces away from 0, which is bigger than 18. So we know that our solutions are correct. All right, so let's try another one. Again, we're going to start by looking at our inequality symbol. Since this is a less than symbol, we are going to have an and inequality this time. So we're going to start by splitting up our equation into two situations. So we have our original, which is going to be x minus 7 is less than 16. So we just start with our original, and then we have our and we're going to do x minus 7, and then we flip the inequality and we make it negative. So now we have less than 16, and then x minus 7 greater than negative 16. And then we're going to solve these equations separately. So to solve each of these, you're going to have to add 7. So then you're going to get x is less than, let's see, 6, 7 adds up to 13, so 23. And add 7 over here. This time it's negative 16 plus 7. So you're going to have to find the difference between this, which would be 9, and there's more negatives. So it's going to be x is greater than negative 9. So when we are graphing this on our number line, we have to go from negative 9 all the way up to 23. So we're probably going to want to count by maybe 3's. Let's put 0 here and see if we can make that fit. So 3, 6, 9, 3, 6, 9, 12, 15, 18, I'm going to have to make it a little bit longer, 19, 20, 21, 22, 23, 24, 27. All right, I got 21 on there. Now go back the other way, -3, -6, -9, -12. All right, so this time it is less than 23. And so we want to have an open circle, and 23 on our number line is just a little bit before 24. Remember, there is 22, 23, 24 in between there. So I'm going to have an open circle at 23, and the numbers less than 23 are to the left. And then I have greater than -9, which means it does not include -9. So I'm going to have an open circle there. And greater than -9 is going to be to the right. So these are going to connect. So we are going to draw the solution line in between those two values. So now if you pick any of the values between -9 and 23, but not including those two numbers, it will make this inequality statement true inside. So for example, 0 is an easy one to pick. So let's try that. So if we plug that back in, 0 minus 7, the absolute value of that has to be less than 16. Well, 0 minus 7 is -7. And we know that -7 is 7 away from 0, which is less than 16. So that would be true. So any of those numbers, including all the decimals, would be solutions to the inequality. So our answer is x is less than 23 and x is greater than -9. Over here, our answers were those, just to be clear. All right, the next two examples are a little bit trickier because before you can do the step where you split it into the two equations, you do have to make sure that the absolute value piece is all by itself on one side of the equation. So in this case, you have this 2 out front. Remember, a number in front of a grouping symbol, like a parenthesis, or in this case, the absolute value bars, means multiplication. And unlike parentheses, where you can distribute into it, you can't distribute into absolute value bars. So to get rid of a times by 2 to get the absolute value by itself, you're going to have to divide both sides of the absolute values by +2. And then you're going to be left with the absolute value of x plus 5 is less than, and then 16 divided by 2 is 8. So now you can split it into the two equations. So we have an absolute value of x plus 5 is less than 8. So if you have less than, you are going to want to choose and. So I'm going to have to write this a little bit smaller here, but we're going to have x plus 5 is less than 8. And so we keep the original one the same. And then you have x plus 5 is greater than -8. So then you have both situations. So the original, and then you flip the inequality and make it negative. And then you solve each one. So each one you're going to solve by subtracting the 5 over. So you're going to get x is less than 3. And on this side, you're going to subtract the 5. Be careful because you have -8 minus 5. And so those are both negative. So you're going to add 8 plus 5 is 13, so -8 plus -5 is -13. So this is our answer, and we can put that on our number line. Let's see. We can probably make it if we count by 2s. 0 right here, 2, 4, 6, 8, 10, 12, 14, 16, -2, -4, -6. So you do have to do a little bit of thinking before you make your number line. Then 3 is halfway between 2 and 4. It's going to be open circle there. And then -13. Oh, I went the wrong way. Can you please not run the water for a minute? I gotta go the other direction, actually. I need 0 over here. Sorry about that. -2, -4, -6, -8, -10, -12, -14, and then 2, 4, 6. Because I want +3 and -13. Open circle at +3, open circle at -13. Less than 3 is to the left and greater than -13 is to the right, so we're going to be between those two on our number line. Okay, for our next problem, we want, in order to solve this one, and I'm going to just rewrite it because I ran out of space here. We do need to get this x absolute value piece by itself, which means we need to get rid of the plus 10. So we're going to go ahead and subtract the 10 from both sides. So that's going to leave you with the absolute value of 2x is less than or equal to, and 5 minus 10 is going to be -5. Okay. So if you remember absolute value is always positive. So the absolute value of a number is the distance a number is from 0. And so a absolute value can't be negative. So an absolute value in this case, like any number that you get here, is going to be positive. And positive numbers are always bigger than negative numbers because positive numbers are to the right of 0. So really anything you get on this side is going to be positive. And a positive number will never be less than a negative number. So in this situation, we would actually have no solutions. Now, it is possible for you to have solutions if it is absolute value is greater than a negative number. So you do have to think about it really carefully because sometimes absolute values can have a negative number on the right side, but it has to be greater than, because you can have values bigger than a negative, but you can't have positive values less than a negative. So this is no solution because it's less than a negative number, which is not possible. Okay, we have a couple more. So if we have less than, we need to look back or try to really remember that less than means and. Then we also need to make sure that we get the inequality or the absolute value piece by itself before we start solving, which means that we need to get rid of the -6. So we are going to have to add that 6 to both sides. And you're going to be left with the absolute value of 2x plus 4 is less than 16 plus 6 is 22. Now you can split it up. Since it was less than, we're going to be using and. So we're going to have 2x plus 4 is less than 22. So the first one, you just write it down without the absolute value signs, and we keep the inequality and the number the same. And then we do 2x plus 4. We flip the inequality and we make the other side negative. So greater than -22. Then we solve each. So in this case, we will have to take 2 steps to solve. First, subtract the 4 to get the 2x by itself, which is going to be 2x is less than 18. And then divide by 2, and we're going to have x is less than 9. And now solve the other side. So it starts the same way, subtract the 4, but because it's negative over here, we are going to end up with 2x is greater than -26. They're both negative, so we're going to add and then divide by 2. We're going to have x is greater than -13. I ended up switching colors halfway through that. Sorry about that. All right, we got a big spread again, 9 to 13. I think I'm going to count by threes again because 13 is close to 12, which is a factor of 3 or a multiple of 3, and 9 is a multiple of 3. So I'm going to start with my 0 right here. I'm going to go 3, 6, 9, 12, 15, and then the opposite way, -3, -6, -9, -12, -15. And then 9 is right here, open circle, because it's not including 9. And less than will be to the left. And then greater than -13. So between -9 and -12, you're going to have -10, -11, -12. Then -13, then -14, then -15. So -13 is going to be right there. And then greater than -13, you're going to want to go to the right. So you got these numbers between -13 and +9. And that would be our solution for that one. All right. One more. So we have this isolated, which means it's all by itself on the left side here, and we have greater than. So we need to remember that greater than is going to be split up using or. And we are going to do that as x over 3 plus 5 is greater than or equal to 1, or x divided by 3 plus 5 is less than or equal to -1. And then solve. So for the left side, we're going to start by isolating the x. So we're going to have to subtract 5 from both sides. And we're going to get x over 3 is greater than or equal to 1 minus 5 is -4. And then we got to remember that the fraction bar means division. And we undo division using multiplication. So we're going to have to times by 3 and do that to both sides, so that we end up with x is greater than or equal to -12. Or same solving steps over here, start by subtracting 5. X over 3 is less than or equal to 2 negatives, means adding. -6 is a total, -1 minus 6. And then to get rid of the fraction or the division, we are going to multiply times by 3. X is less than or equal to -18. All right, let's see. What should we count by? Well, -12 and -18 are actually fairly close together. So I think we can fit these on here if we are careful, and we start maybe at -10 right here, and then go -12, -14, -16, -18, -20, -22, and then it'll be like -8, -6, and you don't have to have 0 on there. We ended up having 0 on all the other ones because we had a positive and a negative, but if you want 0, it's way over here. But you really just have to have your numbers that you're graphing and then some numbers to both sides and some in the middle so that you can see the solutions between. Then we want x is greater than or equal to -12. So we have an equal to, so we're going to need a closed circle, and greater than -12 is going to be to the right. Or the -18 is down here, and we have less than or equal to -18, so you're going to be going to the left. So an or always is going opposite directions, and an and is going together. So come back to checking the very first page where it says the process. So for absolute values less than or equal to, you're going to start with an and. For absolute values that are greater than or equal to, you're going to start with the or. one more thing to remember is that when you multiply or divide an inequality by a negative, you're going to have to flip the inequality. So I'll get you started with just the first one because I really want you to remember this from before. So you're going to start, it's greater than, and if you don't remember, you're going to go back to your front side of your note sheet and you're going to look at this piece right here. So under the process, and it's going to say, if it is less than, you're going to use and. If it's greater than, you're going to use or. So you can tear these pieces apart and have that up so that you can reference it back. You're going to practice enough that you'll remember. So it's greater than, so you're going to use or. So then you're going to rewrite it as negative 6x is greater than 30, or negative 6x is less than negative 30. And then solve each one. And what I want you to remember is that when you multiply or divide, like you have to do in this one, by a negative number, you have to, hopefully you remember, flip the inequality symbol. So we get 30 divided by negative 6 is going to be negative 5. And because we divided by a negative 6, we went from greater than to less than. So you go ahead and finish this problem and make sure that you remember to flip your inequality. And when you're graphing and you're graphing an and, you should be between two values. And if you're graphing an or, it should be going the opposite way. I have made the answer key and I have hung it for you so you can check your work as you go. And then I also assigned you an IXL just to practice solving inequality equations. So if you're struggling with this, go back to just solving basic inequalities and try some IXL. IXL has videos too where you can get some extra help, and wait for me to come back tomorrow. But do your best otherwise to try some of these and just kind of see how it goes. And we will review tomorrow when I'm back. I hope you all had a good break and I will see you soon. Thanks for watching. If I can end the video. Okay, come on.